Okay, so let's see the problem here. So here's a problem. Okay, so the problem works like this. What I have done is there's going to be a common problem where we apply for it for 5 different methods. Okay, there are 5 different methods and we are going to apply the same numbers, numerical numbers, as an explanation. Okay, so the question is, an investment of 12,000 having a scrap value of 600 yields the following returns. Okay, so year 1, 2, 3, 4, 5 are there. Cash inflows are going to be 50,000, 40,000, 30,000, 2,000 and 2,000. The cost of capital is 10%. Compute the following methods and suggest on the decision to take. Okay, so each one we'll try to first find out. Then at the end of doing all the methods, we'll get their answers and we'll suggest whether to undertake this project or not. Okay, so that's what we are going to do. So first we'll start from payback method. So in payback method, we have to start from years, cash flow, then cumulative cash flow, and finally we have to get the answer. Okay, so we'll start. So we have years 1, 2, 3, 4, 5, and we have cumulative cash flow such as 5,000, 4,000, 3,000, 2,000. Okay, at the end of the year, if you see, the investment made of is giving a cash inflow of 2,000, but we also get another cash flow which is the scrap value. Okay, so scrap value is also a cash inflow because we sell the asset and we get the money back, so it becomes 2,600. So that's about the concept here. So here what we are going to do is we are going to accumulate the cash. Okay, so accumulating would be 5,000. So just add this number plus the previous number. Okay, just keep adding them, so it becomes 9 plus 3 will become 12 plus 2 becomes 14 plus 2,600 becomes 16,600. Okay, so that's how it comes. Now we have to find out the payback. Okay, so we'll get the payback. So payback as a concept, the answer will come only in years. Okay, it will come only in years, and the criteria is select the project which has a lesser payback. That is, the lower is the better. Okay, lower the payback, the better it is. So if you want the criteria is lower the payback is better. Okay, that's the criteria here. So of course we'll put it here, and we'll also put a suggestion. Okay, so we'll start from the payback computation. So payback computation is little bit tricky. First you have to find out like how much is the amount that you have invested. The amount that you have invested is 12,000. Okay, the total amount that you have invested is 12,000. Look at in which year. Okay, in which year the 12,000 is recovered. If you see, it is exactly recovered in the year 3. Okay, it's exactly recovered in year 3. So here's in this problem there's no computation at all. Okay, exactly in the 3rd year we're getting it. So what we can do is we can directly write it as the answer is 3 years. Okay, so we can't write a suggestion here because we can't compare it with anything. Okay, we can't compare it with anything, so we can't write an answer saying that any suggestion here. Okay, so this is about this problem here. We don't have any computational things here. But let's see another problem where we might get a computation. Okay, so this is another problem we are going to look at. So these two problems is where we apply all the methods. Okay, so Zco is considering a project which requires an investment of 1,40,000. It has a scrap value of 10,000. The net estimated cash inflows are as follows. Okay, it's 40,000, 40,000, 30,000, 50,000, and 10,000. The cost of capital is 12%. Compute the following method and suggest on the decision to take. Okay, so that's about the concept here. So we don't need to think too much. We can just copy the table. Just copy the table, and we shall put it here. Right? We can put it here. Done. So we'll remove the numbers and all. We don't need them. So let's type the cash inflows. The cash inflows are 40,000. Again 40,000, 30,000, 50,000, 10,000. But if you see, in the last year, they are getting a scrap value plus a cash inflow. So add both numbers. So this would be 20,000. Okay. So again, we have to accumulate. The first number is 0 plus 40,000. Thereafter, it's going to be this number plus this number. So 40 plus 40, 80,000 will be there. 1,10,000. 1,10,000 plus 50,000 is 1,60,000. 1,60,000 plus 20,000 is 1,80,000. So we got our numbers. So we have invested 1,40,000. See in which year we recover it. Like last problem, we are not getting it in as a single year. Okay, last problem we got that 12,000 in the third year fully. But here, if you see, the 1,40,000 is between 1,10,000 and 1,60,000, right? The 1,40,000 is between these two numbers. Okay, that means between third year to fourth year we are recovering. Okay, so our answer is not like between third year and fourth year. You should not like write like that. You should write exactly that number, whether it's like 3.2 years, 3.5 years, 3.9 years, like that. Okay, so you have to find out an answer. How are you going to find out an answer here? So we don't have a formula here, so we have to go with the logical approach. So I'll explain the logical approach. So minimum, how many years does it take to recover the money? See, minimum we need 3 years. Okay, plus what's the total value of the project? The total value of the project is 1,40,000 minus how much money are you getting for up to the third year? Up to the third year, how much money you are getting? You are getting 1,10,000. So balance, how much you have to recover? You just have to recover 30,000. Okay, 30,000. So when can you recover this 30,000? See, this 30,000 you can recover in the fourth year. Okay, in the fourth year. So the numerator is 30,000. The denominator is going to be 50,000. In the fourth year, you are going to recover the money. So put another bracket and solve. You will get a answer. Okay. So if I work out like this, I will directly get the answer. Let's see. See, it comes to 3.6 years. Right? It comes to 3.6 years. So if you are going to use paper and then work out this problem, then you have to solve like this. Okay, I'll solve it step by step. So here, if you see, the numerator becomes 30,000, right? Now 30,000 divided by 50,000 would come to 0.6. When you add, it comes to 3.6. Okay, 3.6 years. Okay, if you're going to solve in paper, this is how you step by step you have to finish it. Okay, so payback wise, it takes this much of years to recover the money. Okay, in some problems what they will do is they will ask you to they will ask you to give it in months. Okay, 3 years is fine, but 0.6 has to be referred in the months they will ask. So what you have to do is you have to put it like this. See, 3 years and okay, and 0.6, it's a years, right, into 12. So that will come to 3 years and okay, 3 years and roughly, okay, roughly this number will come to 7.2 or 7. Okay, 7 months. So the answer would be 3 years and 7 months. Okay, so either the answer can be written as 3.6 years. If the question specifies, please write it in terms of years and months, you have to put 3 years and 7 months. Okay, so that's about the idea and concept here. Okay, so hope you guys got an idea. We will now move on to the next method. So the next method is called as discounted payback method. Okay, so again we'll visit the theory so that we'll get the idea. So discounted payback period method. The discounted payback period method covers calculation of time required to recover the original investment. The method of payback calculation incorporates the time value of money in its calculation, helping alleviate the drawbacks in budgeting decisions that are associated with the determination of payback. Okay, so I think one word is missing here. Okay, see, there is a small drawback with the payback method. In the payback method, we do not take one small concept into account. The concept is, see, the value of 100 rupees is not going to be the same in the first year as well as in the last year, in the fifth year. The value of 100 rupees is more valuable in the first year, and in the fifth year, its value will fall. Okay, its value will fall because of the rise in inflation, or the value will fall because all products and commodities have prices have gone up. Okay, so the purchasing power of money has fallen down. So the 100 rupees received in the first year and the fifth year are not going to be same. Okay, so to avoid this or to overcome this problem, we have the concept called as discounted payback period. Okay.